Hello and welcome back. Today I have another electronic load, and this time it is from TENMA, but it is also known under Multicomp, I think, but in the end they are just Korads. It's the Korad 103, it's the 300 watt version. Korad has very affordable, very interesting priced electronic loads, especially if you just need a basic one. It does have advanced functions. But that is usually more easy accessible through the software. Did I really need another electronic load? No, not really. But the thing was, well, I'm a test equipment addict and sometimes I find a deal, and this was near new and it was super cheap, and it already is normally very nicely priced. And this is what I have now. It is the big Korad in the bottom right there. It is the 2050, I think, 1500 watts. And my first one, the KEL103, has a little bit of a problem that the current sometimes sticks. Then I bought the ease tester. I did this purely because this one goes up to 60 amp, and I think that one was 40. This one is 40, even though it's 1500 watts. So it's only 400 watts, but the 60 amps I like. That one, it was just a nice experiment, because for I think around 160 euros you have 600 watts, 200 volts. That was nice. It's from A-Torch brand, from the battery testers, these. So if I need advanced battery testing, I just use the little one, because it's just, the menu is very easy. Back to the TENMA, or the Korad 103. It boots super fast. It doesn't need any boot even. It has a lot of digits in the current, in the voltage. I like that, I must say. And it is just, as I said, it's very basic price. But it has constant current, constant voltage, current watts, current resistance mode even. And it has a dynamic mode. And you can even do a list programming. But doing that with the buttons is a bit complicated. And then you should just use the software for that. What we see, the big connections are in the front, that is good. What we see more with this smaller form factor on the electronic loads is that the send wires are in the back. That is not really convenient if you put it in a stack, but it looks all very decent. It would be nice if they put also bananas here in the front, but again, you don't see that with too many brands, to be honest. I do see it on the bigger Korad. This one does have it. It is really convenient. Just when you have just lower, like up to 10 amps, it is no problem to use your bananas like this. Of course, if you go above, you use your big cables with, of course, underneath the screws. Well, as a second hand, it looks amazing. It has feet on the bottom. It looks exactly the same as the other KEL series. Same feet as his big brother. Here we have in the back. We have sense wires, and I think there is even a trigger in the back. We have LAN, we have USB, and even old-fashioned RS-232. I want to play a little bit, of course, with almost full power. Let's see if it can do the 300 watts, how much noise it will make. And also I want to see, because it has a lot of digits, do all those digits even make sense? Is it precise enough? I have this little PCBs. It was sent to me by a fellow test equipment addict who had a few of these. And you can put these under the screws, and then you add your own banana terminals like this. And then it's solved. Well, because I have the GW Instack here, I will just compare the voltage readout with both of them, and of course also the current. I will start with the lower voltages and the lower currents, and then later we step up to do the high loads, and then I will use my proper cables. So both are being fed from the same point. They both go directly into the LBO2, and well, it starts with 1 volt. It says 9993, and here we also have the 9993. Oh, I'm actually surprised. Let's go up a little bit. If we go to 4 volts, there starts to be a slight difference, but we're talking about, well, far behind. This is very close to 4 volts here, and here also, but a little bit lower. If we go to 10 volts, we see that the GWin stack thinks it is indeed exactly 10 volts, and it's falling behind a little bit. But we can even calibrate it ourselves, I think. But still, if we take out the digits, it's not bad. But then, yeah, just use less digits. Let's do some current measurements. Let's get back to 10 volts with this one. The limit we can set to 3. And then here we're gonna set to 1 amp. Again, it thinks it's a little bit low, 9961, and here it's a 9981. So we still have, well, we're talking about 2-3 millivolts. So that is not too bad. Well, here it says the readout is 998. Here it also thinks it's 998. And here it is 999. So they all more or less agree. It is here set to 1 amp, but the result is, and it knows himself that the result is different. So what I don't understand why it is not just doing more, because it knows it is not correct from the setting. So I don't know how this feedback system works, but we can add a little bit until, yeah, look at this. This one and this one do agree a lot, and now it agrees here, but here we are a little bit up. I think they were better off just doing 1 digit less, but I wonder how we can calibrate this, because if we can, that would be nice. Oh, at 2 amps it thinks this one agrees again with this one. This one thinks it's a little bit higher again. 18 watts only. 3 amps. Yeah, 998, 998, 999. It's on the limit for this one, but I think I can switch over. That's the only thing I found a little bit harder with this multimeter, is if you want to switch to 10 amps, it is not simply a matter of changing this. You really need to change somewhere here in the range. Switch it to 10 amps. And then we go up. Yeah, I cannot go much higher with this one. I think I have 5 here. Yeah, I have 5. Okay, we can go to 4, and we can just change the current while we are running online. And well, a little bit more, go to 5, 4998, 499, and it agrees with 5 here. Okay, having so many digits is very nice. If it would be correct, they could have cut here the last digits and then, just like here, have 3 or 4 instead of having 5, and then it would exactly match. But again, maybe we can calibrate that. But also don't forget, this one is, I think, new retail, would be like 300, 350, I think, for an electronic load that does 300 watts. Let's put some more power. Let's see if we can get the ventilator running. I put in my volt graph, can run up to 40 amps. Need to be careful not to overstep the 10 from this one. But let's see, put some power, 65 watts. Let's put more voltage. So we have a little bit more power. We can go to 10, so we should reach at least 150. It's blinking. You can use the arrows or just go up, or I think you can even just type. Look at that, and then back on. 9 amps here, almost 9 here, 9 almost, 9 almost. It's not bad, to be honest. Look at this, in the higher currents it matches a lot better. Okay, I put my nice soft silicon, very thick, so we can go to, I think, at least 50 amps with this, but my power supply only goes to 40, and I think we have a limit of 30 right here. So let's try that again. $10 amps. Go higher. Let's see if we can reach the 300. 15, almost 15, almost 15. I think in the higher currents the shunt will probably work better because it is designed for 30 amps. So indeed on the lower currents it becomes less precise. We are reaching now close to the 300 watts. Ooh, very close now. And it's still not making any noise. That's a good thing. I just hear it very slowly. But this is not real cooling. And I think we can go a little bit above. Yeah, 314, still no problems. 20 amps, 20 amps. Let's wait if the ventilator will go on. That is amazing. This must be the most silent electronic load I have seen. It is only very little, the ventilator. And I remember the big Korad was, there it comes, was quite noisy. And we are running over its maximum because we are running 315. And it took almost about 2 minutes for the ventilator to go on. And yes, you hear some noise, but it is not really disturbing. And of course, we are running 300 watts, so of course it can make a little bit noise. It doesn't get that hot. Pretty cool. It probably can handle a lot more. We can test also the constant voltage. It's a bit difficult to test with the power supply that has a lot of power because it will just immediately try its voltage to go up. Well, this one is trying to get it down, but I'm here at 10.035, so it only needs to push down 35 millivolts. And the power supply will try to do that. We have some loss in the cable, so I think we will be fine. But if I try a lot higher, I will be fighting the 40 amps of the power supply there, because it regulates pretty good, that power supply. So let's see. Yeah, so it will try to drop it down by adding a lot of load. So I hope no fuses go. Yes, it does it. So you can see to get the 35 millivolts down, it is putting 8.4 amps, so it's really pulling the power supply, and so that works. It's better to test with these things are better to test with a battery or something, or analog unregulated power supply. Constant watt, so how many watts we have. If I want only 10 watts, let's see, 10 watts. I like the direct entry on 10 volts, so we should have around 1 amp, and we have that. So if I go up, then the current should drop. So if I go to 15 volts, you probably have 0.6, I expected 0.7, and we stay on the same watts, so it's doing that correct. If I drop, it will try to get the current higher and higher. Yeah, that works. Constant resistor mode. Let's do one first before we try to load a lot. One ohm. Load with 1 ohm. Yeah. It will just match. If I go up with the voltage up to 10 volts, you will see 10 amps. So let's do that. Okay, makes sense. How low can we do the resistance? That would be interesting. So okay, now I need to be careful. I will drop my voltage. Can I go lower? Yeah, I can even go lower. Okay. Look at that. Yeah, now my current becomes the limit. So I'm on the limit. So it allows a little bit over, just like it did with the 300 watts. It now also allows a little bit more current. I cannot drop my voltage more, but we can see that the resistance can be very low. Let's do it without load. How low can we go? Look at that. 50 milliohms. Well, I want to have a look inside and I will open it, but it is still cooling, so I want to wait until the ventilator stops. Meanwhile, we can have a look at the software. It did find it on the web, and of course, probably the Korad software will also work, but I think I found the TENMA software. Well, my PC is still booting and the ventilator already stopped, so then I like to look inside first. Okay, that looks very nice. And I've seen it in the other Korad power supplies. They look very basic but very strong. And Korad doesn't fool around. They want to be sure it keeps working. Here also they have 8 FETs, 4 on this side with the drivers also, and 4 on this side. And probably if you have not a 300 but a 200, they have 5 or 6. Maybe it's even shorter. Maybe I can find a photo on the internet. And the ventilator, they did very smart. They just put it on the front and it is kind of a tunnel. So the air that goes out is very effective, and the cool air will come in. They just get sucked in. And the little ventilator that we had, that was actually a separated one. And it seems to be, when we zoom in, that it is actually the current shunt that they cool. So yeah, here is the positive, very big tracks all the way here and also here. And this seems to be, if we look, I hope with the light we can see, this one sits on top of the connection, so this must be the current shunt that they also cool. So very nice. And indeed it says Korad, as we expected. I think it's those IFR, I think. It's 260N, if I read correct. And I have 8 of those, so that is enough. Here we have some protection for distortion. Very nice. Try to get the noise from the line voltage. Cooling. Lots of cooling. Seems to be made for durability. Also sometimes the transformer, because of course the magnetic field can cause distortion on the drivers of the FETs, but you see here it is far away. Sometimes they place it too close by the driving circuits, and then it can influence each other, but this seems like proper distance farther away from the controls. And yeah, linear, not switched. Nicely done. Well, the software just unzips. We have a USB driver that we can start. We have the testing software. It looks the same as the Korad, and we have the test command, which is kind of a communication switch. I installed it already. It was just click, so that's no problem. And well, here we have the software, and we can select if we want the USB or we want a LAN. And if we check LAN, we need to know the IP address. Okay, finding the IP address is a little bit of a challenge. There is no button for the info. There is an identification, but that just shows the serial number, and there is also a COM setting, but that is just for the serial port. The amounts of BPS, it's 115200. So okay, that is the speed of the serial. The light is on, so it is connected to the LAN, but we need to find out, and I cannot get it to display. So I will first put the USB and see if we can do something with the toolbox. Okay, so here we have the toolbox. Let's open that. We need to know the serial number, but I will just click it in, and here it is, 15. Waiting for it to install. So I say, okay, come. No, I need to wait. That was too soon. I remember there was a refresh button here also. Now it's 15. So 115200. I think this is it. Do we have an IDN button? No. We have here dev info. Yeah, here it is. Okay, so here we have the IP number. It's 202 in the end. But I remember there were more buttons. So maybe if I use my Korad tool. Yeah, here is my refresh COM port button. So this software is newer. The other one was 2.1. This is 1.1, but it is actually a higher number. So if I say open serial port, here is my IDN button also. And haha, it is a Korad. That's why they removed the button and the serial number. Pretty cool. Okay, dev info. Okay, let's change the IP address. I think I need 251. That is probably free. Write it to the device. Yeah. I think, is it written? Yeah. Okay, so this tool you can use to set a lot of things. The speed of your COM port, even the communication port. Yeah, different speeds, different things. It's a nice toolbox. So then we go back to the software itself. And well, let's first try to connect with the COM port. The software is a bit slow. Yeah. Do we have 15? We have. The speed was this one. We say connect. Yeah, and it starts running. I see things here in the bottom. We can do on and off. Yeah, the controls work. Okay, let's try the same with LAN now, because we configured it. Disconnect, choose network 1, it is 251, and connect. Yeah, it works. Oh no, it didn't. 7.8 I think. Yeah, I see it running already. Okay, now it works. Yeah, that responds of course a lot faster. We can set the current, well, it's exactly the same as the other Korads. We can do battery testing here. Then you don't need to do it in the menu. Okay, well, pity you cannot see the IP address in the front of the device, but yeah, with this toolkit it is still very useful. Yeah, this error message I also get with the other Korad. That's it, the TENMA 72133210, or would I just say the Korad KEL103. We had a little look at the software, a look inside, and we play a little bit with the simple function that were available in the front. Thank you for watching, hope to see you next time.